Investigation of Curves, Section 1, Equations and Properties of Curves. Video 3, Families of Curves, Parametric Equations. In the last video, we looked at a family of curves that were expressed using a Cartesian equation. In this video, we're going to look at a family of curves expressed using parametric equations. We're going to be using the same sort of mental checklist for the kind of features that we need to look out for. So we're going to look out for points of intersection, stationary points, symmetry, boundedness, asymptotes, cusps and loops. So here's the sort of example that we might be asked to do. Plot the curves with equations x equals cos t, y equals sine kt, 0 less than t less than 2 pi for the cases k equals 1, k equals 2 and k equals 3. So let's have a look at this in our plotting software. Now, in GeoGebra, to express something parametrically, all I need to do is to put it in as if it was a pair of coordinates. So in the input bar, the equations were x equals cos t, y equals sine kt. So as if I was plotting a point, I just type in, instead of x, I type in cos t, and then instead of y, I put in sine k times t, and I'm using a space between them so that it knows I want to multiply k by t. And it's asked me again if I want to create sliders for k, so yes, I want to create sliders. And you can see there it's plotted for k equals 1. It looks like a circle centered at the origin. I'm just going to zoom in on this a little bit so that we can see it a little bit more clearly. There we are. And now I can vary k and see how this changes. It's doing some very interesting things. So I want to see what happens for the particular values that it's asked me to explore. So first of all, k equals 1. And that's just a circle centered at the origin with radius 1. Second one it's invited me to look at was k equals 2. So let's just dial it up to there. And so this time it's intersecting the axis at -1, 0 and 1. It's got this crossing point here and it's still going up to 1 there and down to -1 just there. And then finally it's asked me to look at k equals 3 there. And again you can see I've got some intersections with the x-axis at -1, -0.5, 0.5 and 1, and it's got these points just here, these points down here. So once I've got a sense of what all of my points are, now I want to have a go at sketching these. So here's my sketch for k equals 1. This was fairly straightforward to do because it was just a circle centered at the origin with radius 1. The case k equals 2, in order to sketch this I wanted it going just about vertically through at -1 and 1. I put in my turning points here, here, here and here, and I put this crossing point at the origin, and then I tried to get it as symmetric as possible as I drew it round. And then for k equals 3, very similar, I considered the points where it crossed the axes and just put a light pencil mark in to remind me where they were going to be, and then got my turning points and then tried to draw it as symmetrically as possible. I'm just trying to give a sense of the key points of the graph. It is just a sketch. It doesn't need to be perfectly accurate as long as it's showing the key things that you're going to be talking about. So now I need to state the features that are common to all of the curves and the features that are unique to some of the cases. So first of all, I might look at intersections. So all intersect the x-axis at x equals plus and -1. And then in addition, I've got that k equals 2 intersects the x-axis at x equals 0, and I've got that k equals 3 intersects the x-axis at minus 0.5 and 0.5. For the y-axis, I've got intersections at 1 and minus 1 for k equals 1 and k equals 3. And I've got an intersection at y equals 0 when k equals 2. I've also got some symmetry. I've got rotational symmetry. And I might want to note that that is of order 2 about the origin. And I've also got, I've got infinite rotational symmetry for the case where it's a circle, but for the other two, it's rotational symmetry of order 2. And then finally, I've got some boundedness. So for all of them, minus 1 is less than or equal to x is less than or equal to 1, and minus 1 is less than or equal to y is less than or equal to 1. They're all contained in this sort of square between minus 1 and 1. In this video, you've learned how to investigate a family of curves in parametric form and how to identify relevant features of curves.